Hi, it's Mrs. Valletta again. Listen, I want to go over problem number 6 in the free response on quiz number 1 to make sure that you understand that this is a conservation of energy problem. For those of you who didn't notice, at the top of the hill, we have not only potential energy, but we also have kinetic energy. And that's the energy of the system because we don't do any more work on the system. When we get to the second hill, we have a change of height. And that change of height is equal to the potential energy times mass times gravity times our change in height. And our change of height is only 0.1 meters. So if you're going to do this 3-column method, you want to start by figuring out the total energy of the system at the top of the hill. Realize that energy is conserved, so the total energy at the top of the second hill is going to be the same. And if there's a loss of potential energy, which it looks like there is, that energy has been transformed into kinetic energy. So just looking at this, we know that if we've got a loss of potential energy and a gain of kinetic energy, that our object is going to be going faster at the top of the second hill. Obviously, it's smaller. So that makes sense to us. All right, so at the top, we've got mass, which is 0.5 kilograms. The velocity initial is 1.5 meters per second. Our initial height is 2 meters, and our final height is 1.9 meters. Mechanical energy at the top is equal to the potential energy plus the kinetic energy at the top. You can add this up, but what you'll find is potential energy is 10 joules and kinetic energy is 0.565 joules. Okay. When you get to the top of the second hill, we've lost potential energy. Okay, and so 0.5 kilograms times 10 meters per second square times 0.1. So we have less potential energy here. And that energy has been converted into mechanical energy. So this is at the top. Okay, on the top of the second hill, our new potential energy is equal to 1.9 times 10 meters per second squared times 0.5 kilograms. And so we only have 9.5 joules of potential energy. We've lost 0.5 joules of potential energy, but remember we still had kinetic energy, so that's been added to the kinetic energy, and we had 0.565 joules of kinetic energy. So if you add those two together, we'll have a total of 1.065 joules of kinetic energy. Now that's the fancy way to do it, to figure out how much you've lost here and add it to your original kinetic energy. The other way you can do it is figure out your total potential energy up here, right? And your total potential energy is 10.95. Your original energy of the system was 10.565, and you can just subtract your 9.5, and you'll see that the energy of kinetic energy at the top is 1.065 joules. Comes out the same either way you do it. All right, so how are you going to figure out the velocity? Well, remember, I told you to memorize that the velocity of the object is equal to 2 times its kinetic energy divided by the mass. And when you substitute that in, square root of 2 times 1.065, and I'm not going to write joules, I'll write kilograms times meters squared per second squared, because that's really what's in a joule, divided by 0.5 kilograms. You take the square root of it, and what you get is a velocity of 2.06 meters per second. That's your new velocity. Okay, so most of you got to that point, or you got pretty close, but then you made a mistake on the second half, which is what's the velocity at the top of the third hill, okay? So here's what you have to do for that one. Remember, you have 10.565 joules at the top, and that's potential energy plus kinetic energy. When you get to the top of the second hill, well, you have exactly the same amount of energy. It's 10.565 joules. That's still potential plus kinetic energy. It's still moving there. Whoops, I drew this last hill too low. And at the top of the third hill, well, we said that the velocity is going to be 0. So we want to know what's it going to be when it gets right to the top. Okay, well, that means that all of that energy is now potential energy. So the 10.565 joules is just potential energy. So PE equals mgh. We can rearrange for the height. So you've got potential energy divided by mass and gravity equals height, or 10.565 divided by, let's see, that's 0.5 times 10, so that's 5. And you end up with a height of 2.11 meters. It's really just about conservation of energy. Hope that helps. See you in class.